Welcome to the Applied Digitalization for Oil and Gas course. The course is divided into 5 days. Today we are going to talk about an overview of the digital industry. This shows the benefits that you can get from this training course, which is basically exposure to digitalization and applied digital technologies to the oil and gas business. We will highlight these important points, and these are the main goals that you can achieve after completion of this course. And this is the target audience for the course. Basically, it will be presented as a pre-recorded training. So today we are going to talk about the components of the digital oil field. We're gonna discuss the monitor and control networks, automation systems, and the main lessons learned and the legacy-based data. And finally, conclude with informed decisions, data-powered decisions for intelligent operations using intelligent infrastructures. And this is the agenda for the remaining days. That's the instructor profile, basically educational and work experience in the digital engineering and oil and gas business. So starting with an overview of the digital industry, here we can see the supply chain for the oil and gas, which is the world's largest, starting with exploration and development upstream and moving down to midstream and downstream, spanning multiple operations, high capacity for digitalization, for sensors, for data flow, information flow, control flow, and at the same time, the opportunities around all of this to increase the profit margins and the delivery. We can see here the overview corporate priorities, which is mainly to achieve efficient operations in a safe and secure manner and enable the overall good health and human resources management of the company and the availability and reliability of all resources and assets. And the corporate and engineering priorities, which are very well known, is to improve the economics, mitigate risks, and enhance the delivery of projects in a schedule with a budget, and enable flawless engineering and operations with the ability and agility for the change management practices and compliance with the government and regulatory authorities. We can see here, starting on the left side of the pictures, we can see the data sources where we add the sensors on multiple equipment, such as the pump, to measure the rate and the pressure of the pump. And then we get the control network, where you basically control the equipments that you have here, as well as enable the data analysis to make decisions and send feedback. And this is the demilitarized zone, where we basically have the cyber security protection, and then moving to the client and corporate local area network, where the business aspects are carried out. This is another representation of the monitor and control network, where we see the physical equipment, such as here the pits for drilling, And then the measurements that the sensors achieve, such as the revolution per minute of the bits, and then it goes to the control equipment where we have the, for instance, the geosteering and real-time operational center that are connected to cloud-based servers where we can achieve better control and monitoring of the operation. And here is the security layers to prevent any cyber vulnerabilities. And this is the corporate where we basically do the visualization of the information, allow for collaborative work environments, and achieve analytics to improve the overall performance of the equipments and the operation. We can see here the hyper connectivity and the automation systems that we want to achieve, and we are already making good progress as oil and gas industry. And this shows the data and information flow, the fluids that are flowing through these systems, and how we are able to monitor each and every single drop or even molecule of these fluids to ensure overall safe, secure, and environment-friendly operations. This is the basic process automation, where we are basically having control through supervisory control and data acquisition. And this is done through human machine monitoring, where we monitor these machines to allow for decision processes of the physical and chemical processes that we are after. So this is basically the status of the operation, be it physical or chemical process. We collect the data and then send it for real-time analysis, as well as data historian, where we carry out decisions and then we transform it into action through human-machine interaction or monitoring. This is an example of a real-world process automation. This is a case study that is available online to see how automation is transforming oil and gas traditional operations and the processes. Also, that example and many others can inform us about the value of the data that we collect. For example, the data from compressors, boilers, be it an example like of parameters is the temperature or the vibration of the pump. It can help us get warnings or alarms to keep abreast of happenings and be in context with the operation in a proactive, predictive mode. This is another example. We can see the meaning of the data, give it contexts. What does that value of pressure mean? For instance, it means it requires repair or remediation, or it is normal and it can proceed. This is an exercise that you can carry. You can select system equipment that you are using every day, depending on your department that you're working with. And you can give details about the equipment and the data, the parameters that you want to gather and access to check the health of your equipment. And then what is the objective? Is it to replace that equipment? Is it for maintenance? And what is the best way to set metrics and KPIs for your operational excellence? This is applicable for all equipment that you are working with, and this is a very useful exercise that can help you extend, for example, the life of your assets. In general, the I field will continue to expand. This is supported by advances in the cloud computing, big data analytics, the Internet of Things, and a lot of work will be done remotely with mobility. And the web will continue to be an enabler to reduce costs and support real-time work environments. And finally, this will skyrocket the volume of data and will generate more opportunities for data management and data analytics. Just very important definitions that should be utilized and differentiate between digitalization, and digital transformation. We can see that digitization is basically the converting of analog or manual items into digital versions, and digitalization is basically changing a process or workflow from manual paper into a digital workflow. And finally, digital transformation is the application of the previous 2 points, digitization and digitalization, to make a lasting impact over your organization to achieve the ultimate objectives of digital transformation. The lessons learned through digital transformation journeys for a lot of companies, especially the oil and gas, is that these models are very complex. They are multidimensional, multi-organizational. The security challenges are new and emerging. Those they should be accounted for in the early design, and the logical or digital representation can never be an exact replication of the physical model. For example, the behavior and the culture cannot be represented in the logical representation. The key here is to achieve operational and security efficiency, and you make consensus between the two requirements to achieve successful digital transformation. And the decisions made here need to account for the life of the assets, because most of oil and gas assets are long-lasting, 50 years and plus. The decisions need to account for agility and change management. The Generation Y and their culture or psychological aspects of mobility and digital over-reliance will manifest and will have implications in the workplace. Therefore, it's important to account for this early in the process and have clear defined policies, regulations, and compliance. Last but not least, the digital transformation is no longer a technical challenge. The technologies are already there, and we can be trained to apply them. But the key here is to have a change management culture and mindset that cultivate digital transformation to ensure smooth transition. As far as leadership, there is a need for metrics and KPIs to monitor the progress made for digital transformation and connect the digital transformation to the corporate strategy to get the board of directors support, as well as there is no one-man show that can do it all. Seek for alliances and partnerships with experts and service providers and consultants to be able to develop inherently safe, inherently secure digital transformation programs. And I would like to overemphasize that the technology on its own is not going to make any big changes or add values, but rather it's the processes that are going to apply those technologies to achieve the sought after goals. The digital skills need to be leveraged, and the IT and OT convergence opportunities will have to be accounted for, and this will result in a lot of DevOps, development ops uh, projects, and the sensor data, the long leap is going to add the business value from the sensor out there in the field all the way to the corporate office to generate value. Last but not least, the human will always be there, regardless of how much automated we are. The human will be there to monitor and overlook the performance of these automated systems. This shows an example of information and data gathering in the field. You basically develop your idea and capitalize on opportunities to make the most of these sensors, and keep into account the long lead of the data that you collect and how it would relate to your business goals and vision. This is an example of a sensor populated case. It's available on the Society of Petroleum Engineers. This is the reference paper to retrieve it. And you can study this case because there is an exercise about it that shows the impact of these smart technologies. You can study the paper and make conclusions and recommendations about how the smart technologies and sensors has impacted the McKinsey case, and identify uncertainties that need to be addressed, and discuss the risk issues in terms of how probable they are and what is the implications that they can have, consequences, and how we can add more emerging technologies that are emerging today to prevent such incidents, and the issues that require to be considered, such as the cultural aspects, the generational gap of the workplace. This concludes day one.